Welcome back, everyone. Today, we're diving into a game-changing topic for developers and testers alike. When is the perfect time to start testing in the software development lifecycle? In this video, we'll cover each stage of the SDLC, from requirements gathering to deployment, with practical examples and tips on integrating testing. Stay tuned to discover how early and continuous testing can enhance your development process, reduce costs, and ensure top-quality software. Let's get started. Testing should kick off early in the software development lifecycle, SDLC, and continue throughout. Early integration of testing is crucial for spotting and fixing issues, cutting costs, and ensuring software quality. Let's break down when testing should happen at each SDLC stage, with practical examples and additional details. Requirements gathering and analysis. Initial review. The testing team reviews and analyzes requirements to spot ambiguities, inconsistencies, or testability issues. This proactive approach helps prevent costly rework later in the development process. Example: if a requirement states that a system should be fast, testers can prompt stakeholders to define what fast means in measurable terms, like a response time of less than 2 seconds for any user action. Feedback. They provide feedback to business analysts and stakeholders, ensuring requirements are clear and testable. This collaborative process helps create a shared understanding and aligns expectations. Example: if a feature is described vaguely, testers can request more specific details such as, the system should process 1,000 transactions per second, ensuring clarity and setting a measurable benchmark. Test planning. Begin outlining the testing strategy, test objectives, and resource requirements. This foundational planning ensures that testing activities are well coordinated and aligned with project goals. Example: planning a strategy for performance testing if the application needs to handle high user loads, including tools, metrics, and scenarios to be tested. Design. High-level test cases. Develop high-level test cases based on design specifications. These cases provide a blueprint for subsequent detailed testing activities and help ensure comprehensive coverage. Example: creating test cases for user login functionality, ensuring different user roles are covered, such as admin, regular user, and guest user scenarios. Design review. Identify potential design flaws, usability issues, or security vulnerabilities. Early detection of these issues can prevent significant problems during later stages. Example: during a design review, testers might spot a potential security flaw in the authentication mechanism and suggest encryption or multi-factor authentication. Early collaboration. Work with the design team to create a more testable and maintainable system architecture. This collaboration can lead to better design decisions that facilitate easier testing and maintenance. Example: suggesting modular design principles to make unit testing more effective, allowing individual components to be tested in isolation. Development. Unit testing. Developers should verify the functionality of individual software units. This practice ensures that each component works correctly before integration, reducing the likelihood of defects in the integrated system. Example: a developer writes unit tests for a function that calculates discounts, ensuring it handles various discount rules correctly, such as percentage discounts, fixed amount discounts, and conditional discounts. Integration testing. Ensure integrated modules or components work together as expected. This step helps identify issues that may arise from interactions between different parts of the system. Example: testing the interaction between the payment processing module and the order management system. verifying that payments are correctly recorded and orders are updated. Functional and non-functional testing. Start executing tests based on previously created test cases. Functional tests ensure that the system performs its intended functions, while non-functional tests check performance, security, and usability. Example: running functional tests to check if the shopping cart updates correctly when items are added or removed, and non-functional tests to ensure the website loads within 2 seconds under normal user load, considering peak traffic conditions. Testing phase. Dedicated phase. Perform various tests like system testing, integration testing, user acceptance testing, UAT, performance testing, and security testing. This thorough examination ensures the system meets all requirements and is ready for deployment. Example: conducting UAT where end users verify that a new inventory system meets their needs and works as expected, providing feedback on usability and functionality. Validation. Validate the software against requirements, identifying any defects or issues to ensure overall quality and reliability. Comprehensive validation helps build confidence in the system's readiness for production. Example: using automated tools to perform load testing on a new e-commerce platform to ensure it can handle peak shopping times, such as Black Friday sales, without crashing or slowing down. Deployment and maintenance. Post-deployment testing. Conduct smoke testing or sanity testing to confirm the software functions correctly in production. This step verifies that the core functionalities work as expected in the live environment. Example: after deploying an update to a banking app, perform a quick smoke test to verify that users can still log in, check their balances, and perform transactions. Continuous monitoring. Monitor and test during maintenance to spot any issues or performance degradation. Continuous monitoring helps maintain system health and performance over time. Example: using monitoring tools to track server response times and alert the team if they exceed acceptable thresholds, ensuring prompt resolution of performance issues. Regression testing. In modern methodologies like Agile and DevOps, testing is even more integrated into the development process. Practices like test-driven development, TDD, continuous integration, CI, and continuous testing, CT, emphasize testing at every stage. Test-driven development, TDD. Developers write tests before code, ensuring that all new code passes the tests. This approach helps catch issues early and improves code quality. Example: writing tests for a new feature in an app before actually coding it, ensuring that the development process adheres to the specified requirements and behavior. Continuous integration, CI. Regularly integrating code changes into a shared repository, followed by automated testing to catch issues early. Example: using CI tools like Jenkins or GitLab CI to automatically run tests every time code is pushed to the repository, ensuring that new changes don't break existing functionality. Continuous testing, CT. Continuously executing automated tests throughout the development process, providing rapid feedback on code changes. Example: implementing automated testing pipelines that run comprehensive test suites, including unit, integration, and end-to-end tests, every time changes are made. We've learned that starting testing early and continuing it throughout the development process helps catch issues sooner, cut costs, and ensure high-quality software. Integrating testing at every stage makes the development process more efficient and effective. If you found this video helpful, check out our other videos. See you next time.